Thank you for listening to this video. I'm just trying to explain the pipeline tuning for the project one of the nanodegree for self-driving cars. So for the project one, you build actually a pipeline to tune or to process the images to identify the lines in the image. So this is the original image, and this is the final image after we are drawing the lines boundaries on it. To do that, we went through a pipeline of 5 steps. It's explained in each course, in the course for each step, or each step is having some kind of tuning. For example, this one is having a blurring image, is taking some parameters, which is by changing this, the output will be differentiated, which is impacting again the input for the next step. So to try that, we try it first on the images, and then we are applying this on a video, because the video is a sequence of frames, which is actually a sequence of images. One thing that is not really explained in the material is that's something that I created, which is how I identify the mask. So if I have an image that's the area of the image, I use to build this polygonal shape. I use 4 parameters: x up, which is this area, and of course the length is the double of x up, and x bottom and which is this path, which is the this line is the double of the x bottom. Again, the y up, it's the reference of this line from the maximum of y, and please take care that y is from 0 to the end. This is y. So, and this is y bottom. So by changing these 4 parameters, x y bottom, y up, x bottom, x up, you can identify the area as we are going to see that. So now for how we can do that, we first we use it for the Python. You can find how you call this by calling -h. So -h will give you the details about the parameters. For the image, we run the image like this one. So you can see for each step, for the blurring, there are parameters coming out of it. All the parameters are shown in the control panel, and each step is showing the outcome in a separate window. So if, for example, we can change this, you can see that the outcome of the blurring image is impacting actually the rest of the images, and the clarity of the images actually. So if I change the x up, so I'm changing it and it's up to, it could be like a triangle now, or I can extend that. I can use x y up to extend the path, and of course if I getting larger, there are a lot of noise, so we need to reduce that to this level, which is a good level, and we can increase even the thickness of the red line. So you can see that's changing here and here. So this is how you apply that on an image. And if you are having you are done with the configuration, you save it in a JSON file. Then you apply that on a file, on a video. So you can take that, and these are the parameters, change it and saving it. So you can take it after that to use it for the video. and you can take this outcome, the configuration from the specific location, and you take it, and output of the changes will be in the output videos. So we can see that as well. So you can see when we change the outcome, it's applying on all the scenes in the video. And we also, if we change the bottom, we can see the impact of that on the rest of the chain. So if I use, for example, Y up, that's hiding a lot of lines, so it's only showing this part of the lines. So this one is not actually a good one. We need to increase that till having a value of 39 or 40. And again, we can increase the thickness. We can play with the values for the threshold, minimum threshold and maximum threshold, which is getting a better line clarification. That's how you use the tool. And of course, you can, after that, you can have the selection of the parameters, and it's saved in a file, a JSON file. That's you can see it here as the output of the for the videos, like this one, for example. So these are the outcome of the files, so you can save them and you can read them again. Okay, thank you for listening. I hope that's a good tool. The tool, you can find it in a GitHub, and the resources will be under the video. Thank you.